So if we can have small, discrete units that we can deploy, hopefully make life better. And this is the promised land and why we all sort of decided to kind of rewrite our monoliths into microservices. I don't think anyone actually starts out with, I'm going to have the most brilliant architecture from the get-go. Everyone starts out with, I have to ship something and get something working, and then we have something terrible. And then we go, okay, this is unmanageable, and now we need to re-architect. I fall into that camp. So, if you screw this up, these are sort of the cuts that I want to. If you go to microservices, and these are the things that will hurt you if you don't look after them. Testing is difficult, resilience, failure cascades between services, and observability is very important when you want to figure out what happened. So, integration testing, it is not that easy when you are living in services land, and more often than not, what will happen is, why don't we just test this in production, because provisioning everything is difficult. Who's done this? Some of you are lying. I don't believe that there's only so many few people who screwed this up. You know, everyone knows it's a bad idea, but you end up doing it anyway because expedience. So integration testing is hard. Full end-to-end testing is hard. I'm not talking about, let's assume we're all good people and we all have proper unit tests and we have proper coverage. Resilience. How many services can fail? How many discrete services can fail before your application goes down? What does it mean to have high availability in your microservices landscape? Do you have a single state somewhere? Do you have a single database? Do you have a single file system? Do you have a single representation of your global state? Or are you truly don't have any states and then, hey, you're lucky? Where is your configuration and how many different places have you deployed it? And are they all the same and consistent? Advanced technology is not working. Okay. So failure cascades, and how do you deal with dependency failures? So let's just say this is some graph of some set of services, and if one node goes, there is going to be the upstream of that service is going to have problems. How are you going to deal with this? Have you thought this through? Who failed? Where? It's 5 a.m. Do you know where all your log files are? What are you going to do? This is pre-coffee time. You're going to get a phone call. You're going to be in bed. You're going to be groggy. Where are you going to go to look for problems? You have to have clear observability. Otherwise, distributed systems are hard. There are a lot of tools that make it easy, but it's just fundamentally difficult. So, but we all like microservices, and it's still a lot of fun, and we want to be happy. And my personal motivation around is I want a polyglot of languages. I know a lot of people will disagree with me. It's like, but if I can't have fun, what's the point? And I don't want to be in a rut, and I want to try different things. And for me, microservices are that way of doing it. Is like I can mix and match the appropriate runtime, the appropriate language, and as somebody said in work said to me, like we can think of HTTP as the universal dial tone, or gRPC, or whatever, doesn't matter. But they will, if you let them run around in chaos, they will come and bite you in the ass. Puppy is oddly appropriate for this. So, testing. We probably won't be able to do full integration testing because probably it hurts to bring up to the full set of environments. But you can work around it. Contracts and versions of contracts are your friends. At least if you can go, we have hard boundaries. We have like effective, so as Sam Newman would say, he's the guy who wrote the O'Reilly Microservices book, have effective bulkheads between, and that can help you. Docker is pretty handy if you can, or Kubernetes, if you can set it up and that you can orchestrate your entire thing in a set of YAML files or whatever, that you can go, yes, bring me up an entire environment of these 50 things. And it can do this in an automated way. That does really help, and it's been helping me a lot. Or maybe you can make that decision and you go, yeah, production is cool. We'll just do it in production and it's fine. That's a business decision. So resilience and failure cascade. Services will be flaky. Scale and distribute. You have to think about at what scale you're running. Is your microservice just going to be a single process in one place, or are you going to have 20 instances of it? And it's cool that if half of them go away. It's cool if 2/3 of them go away. Great. But then you have to think of, fine, I'm going to run 20 instances. Where am I going to run those 20 instances? What is my isolation level? I'm running on some container farm, fine. Container hosts go away, that's cool. Have you made sure that they're all not scheduled on the same host or the same data center or availability zone? So these are like, really need to take these into account. Another thing is failures will happen, just take that into account and have the concept of circuit breakers in terms of if something below me if I get a high voltage and it's coming through, let's just blow right here and blow loudly. Fail as early in the process as possible and fail as loudly as possible so you can, you know where to go look rather than I failed, end user is experiencing problem here, but the real problem issue is way all the way over there. So how are you going to propagate the error? If you can propagate the errors, always do. Propagate the error all the way up as high as, you may not be able to expose it to the end user, but propagate the error to the highest level of the consumer. Again, back to observability. Log aggregation is key. I'm sure most people no longer are in the position of they can run their application on 1 or 2 machines and they can SSH into their 1 or 2 machines and tail their 1 or 2 logs. In my small team, I have on the order of 80 to 90 discrete network services running around doing their things. There's even with, when I had 5, I could use there's a great tool called multi-tail, which is basically SSHs into all your machines and runs tails and aggregates them into a single terminal. That doesn't scale out to 80 or 90 or 100 or 200. You need to be able to aggregate your logs. And you need to be able to monitor, and you need to have this thing I'll talk a little bit more about, have Canary tests, the simpler, same as having a canary in the mines. So, and if you have monitoring, please have alerting, otherwise what's the point? It's great. There's some information around, yep, we're experiencing downtime, but if nobody knows about it, you still can't be proactive. It's difficult. I know people screw this up all the time. I know people screw this up. I screw this up all the time. So one of the first things is if you can't do automated deployments, This is kind of a step 0 fail. Stick with your monolith. You have to have automated deployments. If you need to do this by hand, it is going to get out of hand so fast. Package all the things. Package everything. Packages are, be it Python packages, be it RPMs, be it debs, be it worst case scenario, it's a frigging tarball. The ability to reason about one single binary asset is really important. That this service is tied to this asset, and this asset it contains everything required. This is something like I've learned, like if fine you have a service that depends on 40 different libraries, that's cool. Create a virtual end, package up that virtual end as a discrete unit, and deploy that unit with all its dependencies. The more you can do this, and if you have to do duplicates, so what? Disk space is cheap. No one cares about if it's going to cost you another 100 megs of disk. Having a single artifact that you can tie to a single service will really help you reason about what's running, what versions, what the whole thing is. That's important. It will save you. Okay, I did say about logging before. Aggregation is key. I'm using Elasticsearch, Logstash, Kibana. It's a lot of Java, and I end up using a lot of Java. And I don't really like Java, but you could just use syslog and get it aggregated that way. There are many different ways to go about this, but aggregation is really key. And one of the things I want to say and mention is please use correlation IDs between all your services. How are you going to trace a request comes in from your consumer and it has to touch 7 different things? It basically will flow through 7 different nodes, 7 different services, and if something goes wrong, how are you going to construct that request, the life cycle of that request? So a simple thing I recommend is if nobody gives you a correlation ID, make one. If somebody gives it to you, respect it. But it is your responsibility to accept it, and it is your responsibility to give it to your downstream. Friends don't let friends don't do 2 things, actually. It's not relevant to friends don't let friends implement their own crypto, and friends don't let friends implement their own consensus building algorithms. Use etcd or console. I'm not a fan of Zookeeper. Again, it's kind of old and clunky, and yeah, it's a good idea in the time, but we have better right now. And the talk going on in the other room about you want to be in a sort of, you can be in mixed mode. Yes, sure, run Golang, run Python, run everything. So etcd or console, this is going to give you a couple of different benefits. You have your, this is your distributed, effectively this is a distributed hierarchy, which is easy to use. Everybody already, in most enterprise, people have this already, and it's called LDAP and Active Directory, but it's really, really hard to use. This is just a lot easier. And plus, IT infrastructure really, really guard Active Directory, so you can't just go around sticking arbitrary things in there. And we can use it for our distributed configuration. We can use these things for services discovery, and sooner or later, you're going to come across and you're going to have a need for distributed locking. And how are you going to reason about a single view of the truth? So both, I'm a big fan of etcd and console. Console has some nicer things, but I started out with etcd first, so that's where I am personally. So on more toolings. So this is something that I thought about for a while, and I kind of settle on this pattern: uniqueness, configuration, and bootstrapping. So I think I only ever need 4 pieces of information to uniquely bootstrap any service. Basically, because I need to have some sort of hierarchy, an application group, an environment, a service name, and an instance ID. 2 of those things are baked into the source code, and 2 of those things are runtime configuration. The all caps are runtime configuration. This is enough information to bootstrap everything. This is the minimum, it's completely flexible. You can bootstrap anything. After this, the application, once a service comes up, the network service comes up, it should be able to interrogate and figure out everything else it needs from console or etcd to manage. I have debates with some of my colleagues on how much should be baked into the binary artifact or not. But if I'm running multiple instances of the same service with slightly different configuration, okay. So once we have this, we can have service discovery. So it's great. I mean, we have bootstrapped our configuration. Now we know who we are, so we can tell other people about it. Both etcd and console give you really nice primitives for this kind of operations. Console is really nice because it's also a DNS server. So if you use console, and you can then it will advertise on your behalf, and you can just do, your resolution becomes really, really simple. It's just resolve some DNS. Or an etcd, which you don't have a DNS server, but you can very easily plug that in. So once I know, I can tell others, and then if a consumer needs to resolve, what are they really looking to resolve? They're looking for an instance of a service name that lives in some environment. And once they have that much information, they can go query either DNS or etcd and figure it out and go from there. Once you can publish, you can resolve, and you can manage failure detection. So once you've published something, it's really also important that there's sort of like a heartbeat. That if you don't have a heartbeat, your service dies, and then somebody's trying to use a dead endpoint, it's gonna bad time. So both etcd and console, really good primitives for this kind of like TTLs. If you don't tell me that if you don't have a heartbeat, I will delete you. So Hadoop, and so they're all like Zookeeper guys, I believe.
No, like in Hadoop you have name node and
yeah, but that's based on top of Zookeeper. So similarly, that all came out of Yahoo. When Yahoo, I guess, were still a company. Zookeeper was the first of Zookeeper, etcd, RxCD, and console. They're all hierarchical consensus systems, and Zookeeper was created to be able to do that for Hadoop, because you need to be able to resolve who's around, who's not around, who died. So metrics are really important, and I used to be a big Graphite person, and I moved over to Prometheus. When I was a big Graphite person, it was, everything. I don't know if this is useful. Put it in anyway. We'll figure it out later. Great, and then it's like, what am I looking for? One of the differences with Prometheus is you're responsible for providing a metrics endpoint in your service, which means all of a sudden you have to write code. And once you have to write code, you're going to start to think about, well, what do I want to expose? What's important to me? What do we care about? This is intimate to this application or to this service. That that making you think is the really important bit. And it will seem counterintuitive, and it will seem we're doing it the wrong way. But once you make that leap that I really care about the internal metrics of my application or service, and these are the things that I really want to expose, because when something happens, this is what I'm going to key off. That is important, and that will make changes. And also, labels are a lot better, because in Graphite, most people know, like you just have a dot-separated hierarchy. In Prometheus, you can have arbitrary multiple labels on every metric. And depending on the how you select your labels, grouping is a lot easier, and correlation then becomes a lot easier. And the query language in Prometheus is also a lot richer. Prometheus comes with Alert Manager. Use it. It's a good starting point. You can use other things. It will integrate with various other cloud-based services. Personally, for me, I'm kind of stuck in a land of I have to use most things that are self-hosted because of I work in an enterprise, and we can't it's not always easy to expose our internal system state to external third parties without going through effectively end up talking to lawyers. So it's easier not to talk to lawyers. Okay, so implement these endpoints or some variants. This will help. So slash metrics, because you need to give Prometheus a place to scrape your metrics from. Prometheus, you don't push metrics to Prometheus, it pulls it from your application. Slash health, again, you will want to do monitoring, and it will be very beneficial. My recommendation sort of is have getting your team and your colleagues to agree on, say, a very simple, like a traffic light system. And you can have additional data in there, but have at least a green, yellow, red, that even if somebody doesn't know about your service, your consumer can very easily reason about, yellow, okay, maybe I will go talk to the owner of the service, or your infrastructure people can go, this is red, we need to wake those guys up. And configuration. Don't expose everything, but be thoughtful of what internal configuration will your consumers find useful. Maybe it would be useful for them to know what your upstream is. So all of these things require some thought. So the Canary is really important. It is a lot of people just have like a post deploy. They run a set of smoke tests. I kind of think if it's important enough to check that your system is up and running post deploy, it's important enough to run continuously. Sam Newman calls it synthetic transactions. I personally just go with, this is sort of the canary in the mines kind of a thing. This is your first indication that something is going bad. Before your end users feel it, you feel it. Now, the main thing to consider here is you're consuming full-on actual resources when you're running something like an end user through your system. So how often you want to run it, what kind of load you want to put on your system, because this should ideally exercise every part all the way to the end. So you're consuming your system resources for effectively monitoring purposes. So again, be a little bit more thoughtful around that. So maybe microservices are not for you. Maybe you're happy with the monolith and just stay with it. And it's okay, that's not a bad thing. But the worst scenario to be in is don't have the distributed monolith where you have the worst of all possible worlds. I'm happy to chat about this now or later. It is just kind of my viewpoints on I like microservices, but how to do it safely. So I'm happy to take questions now, or you can grab me later.